First, let's look at the concept of maintenance. The ad hoc development process will cause software maintenance problems in the future, so it will increase the overall software cost. Typical software maintenance problems are as follows. Maintenance may result in side effects from code, data, or documentation. It is possible that the reliability of the system is degraded, and maintenance costs and resources can increase. Failures may occur due to unstructured maintenance and procedures, organization, and resource management. Maintenance personnel may lack skills. This is typical maintenance problems. There is a 60-60 rule in software engineering. The cost of maintaining software is about 40% to 80%, usually 60% on average. 60% of the maintenance costs are spent in maintaining and enhancing with new features. Therefore, many companies and public organizations are spending the cost of applying a variety of tools and techniques in establishing operational and maintenance processes in order to improve IT maintenance. In particular, IT operations and maintenance of public organizations are usually performed through outsourcing. As a result, the IT Outsourcing Operation Management Manual issued by the government contains a guide on operation and maintenance management within the service performance management process. In addition, there is a strong demand to document and quantify the delivery levels and content of IT service operations between IT service providers and IT users through ITIL Service Level Agreement. Software maintenance is the last phase in the software development lifecycle. This is an operational focused phase that extends the life of the software. It also refers to a series of tasks that correct errors, meet original needs, and improve functionality and performance. A series of all software engineering tasks that take place after the software has been delivered to the customer. They are eliminating defects, improving performance, and adapting to the changing environment. The purpose of software maintenance is largely to improve software performance and correction, port and modify for operation in new environments, and take a series of preventive actions. Software maintenance is also a very important step for the following reasons. First, maintenance costs are growing faster than development costs and software budgets. Second, the complexity of software makes it more difficult to manage documentation and its management costs. Third, the length of maintenance period beyond the development cycle emphasizes the importance of management. Finally, the maintenance is increasing because the choices of package-based development are spread over service integration development. Software maintenance typically involves the following steps. They are maintenance requirements, understanding the current system and analyzing requirements, modifying, testing, verifying, validating, reporting results, and using or discarding the systems. The key activity here is requirements analysis, which aims to quickly identify how maintenance requirements affect the current system. This impact analysis can be easy or require enormous effort on the other hand, depending on how easy the maintenance of the software on the current system is. Ease of maintenance is a characteristic of software maintenance difficulty. There are the following types of ease of maintenance. Ease of use is a characteristic of how easy the program is to understand. Modifiability is a characteristic of how easy it is to modify a program. Testability is a characteristic of how easy it is to show the accuracy of a program. Therefore, any activity that improves the ease of maintenance at the software development can meet user requirements continuously and economically respond to the rapidly growing maintenance costs. So let's look at activities that improve ease of maintenance. The analysis activity determines the needs and constraints of the customer and demonstrates the feasibility of the target product. Several types of standards and guidelines should be established for ease of software maintenance. Design activities should be leveraged to emphasize clarity, modularity, and ease of change. In addition, implementation activities should adopt a standard structure and a simple coding style. Supporting documentation requires guidance and test documentation for maintenance activities. Now, let's discuss the types of software maintenance. Software can be categorized as a maintenance performed by the enterprise itself and a maintenance by external vendors, depending on the maintenance subject. In addition, the maintenance can be classified as follows. By reasons of maintenance, they include corrective maintenance, adaptive maintenance, and perfective maintenance. As corrective maintenance is maintenance caused by errors, it identifies and handles processing errors, execution errors, and implementation errors. Adaptive maintenance is to respond to changes in the environment and change the functionality and performance of the software to maintain its original performance. This includes modifications due to changes in hardware, operating system, and database. Perfective maintenance is a change to further enhance the software functionality and performance, thus adding new functions, changing the output form, improving the user interface, and improving the response time are all perfective maintenance tasks. Time-based maintenance includes scheduled maintenance, preventive maintenance, and emergent maintenance. Scheduled maintenance is to perform regular maintenance according to pre-planned. Preventive maintenance is the task of improving ease of maintenance or reliability. This is also the case for changing structure of existing software into new one. Emergent maintenance may be carried out if post-approval of maintenance is required. Maintenance by subject is data program maintenance, documentation maintenance, and system maintenance. Data program maintenance is handled in the case of data conversion. Document maintenance can be a change in document standards or handled others as needed. System maintenance is the maintenance to handle the operation and failure of the system. Software maintenance is a continuing activity throughout the lifecycle of a software product. Modification requests are recorded and tracked, impacts on proposed changes are identified, codes and other software artifacts are modified, tests are run, and new versions of software products are released, and the training and day-to-day support are provided to the users. Flieger, author of Software Engineering Theory and Practice, says, maintenance has more scope to track and control than development. The software maintenance standards is included in the software operation process and the maintenance process of the technical processes in IEEE 12207 software lifecycle processes. This content includes the definitions and the maintenance plan requirements for software maintenance activities and tasks. ISO IEC 14764 is replacing the existing IEEE 1219 and includes content for those responsible for the areas of backup, recovery, and system management performed by software operators and additional development and quality assurance. IEEE 12207 identifies key activities in software maintenance such as process implementation, problem and modification analysis, modification implementation, maintenance review acceptance, migration, and retirement. The recently published Software Engineering Body of Knowledge 3.0 includes comparisons of various standards in Chapter 5, Software Maintenance, and describes the following 6 maintenance-specific activities. First, understanding the program is an activity that identifies what the existing system is doing and how each part is connected. Transition is an activity that controls a series of activities that seamlessly transit the development organization to the maintenance organization. Change request acceptance and rejection is an activity that determines whether the maintenance organization accepts or rejects by analyzing the extent of the size, efforts, complexity of a particular request. Maintenance help desk is an activity in which end users and maintenance organizations assess, prioritize, and estimate change costs for their needs. Impact analysis is an activity that identifies areas affected by potential changes. Finally, Maintenance service level agreements and maintenance contracts are the activities such as the maintenance service level agreements and maintenance contracts that specify service and quality objectives. The maintenance process will proceed to kick off analysis of problems and fixes, implement fixes, maintenance review and acquisition, transition, and software disposal phases. Firstly, in the kickoff phase, we plan to carry out maintenance activities and detail work, develop procedures, and document them. The problem reporting and modification request processing procedures will proceed as well. Analysis of problems and fixes phase analyzes the impact on the system. Therefore, it defines whether this is maintenance for correction, improvement, prevention, or adaptation of a new environment. Next, it defines the size, cost, and time of the fix, and it evaluates the importance of performance, safety, and security of this maintenance. Therefore, at this stage, the recreation, verification, and correction of the problem and alternatives to implement the changes are also considered. Implement fixes phase analyzes and determines which documents or software units and versions need to be modified. So it is also a phase of using the development process together to implement the modification. In maintenance review acquisition phase, you will review fixes with the organization which has authority to modify. Once the revision has been completed, they will be approved. During the transition phase, it verifies that the software products and data in the transition meet the standards. So, when a system or software product is transitioned to a new operational environment, any software product or data created or modified during the transition must be guaranteed to follow this standard. You also need to develop, document, and execute a transition plan. And if you have a transition plan, it will notify and run concurrently with your existing system to transit. The data used or related in the old environment is accessible according to contract requirements for protection and audit. In software disposal phase, the software product is discarded at the owner's request. Thus, the development of disposal plans, notification of disposal plans, and activities, concurrent operations and user training, notification to relevant persons and document archival, and data management activities are performed. IEEE EIA 12207 defines maintenance personnel as the organization performing maintenance activities. Sometimes it refers to individuals who perform maintenance activities to distinguish them from developers. The maintenance person can learn a lot from the knowledge of the developer about the software. Meeting with developers or getting involved early in the development process can help reduce maintenance efforts. In some cases, however, they may have difficulty in maintenance because developers have moved to another job or have not been contacted. Therefore, the maintenance person should take over the developed products and support them immediately. It also needs to be evolved and maintained gradually over the entire life cycle of the software. The following table shows the activity-specific owners in a typical maintenance phase. Each activity owner is responsible for performing its maintenance activities. In either case, the Maintenance Management Committee approves or rejects the changes, and reviews and finally approves the changes. Now let's discuss the concepts of re-engineering and reverse engineering. Re-engineering considers the problem that maintenance costs make up the bulk of software development costs. This is a representative technology to improve maintainability and quality and reduce maintenance costs through modification and improvement of data and functions of existing software. Also, re-engineering is the task of adapting an existing system to a widely used programming standard, reconfiguring it in a high-level language, or converting it to use on other hardware. Re-engineering is defined as the examination and alteration of software to reconfigure existing software into a new form, and may also include the following new implementation. Re-engineering is the most radical and expensive change, but it is also done on small changes. So, re-engineering is often used not only to improve maintainability, but also to replace old existing software. Generally, after reverse engineering is performed, re-engineering is carried out again considering changes. So let's look at what is the purpose of applying reengineering. It facilitates to improve the maintenance and understanding and transformation of the current system, reduce maintenance costs and time. It also facilitates standards and compliance and the use of case tools. Reengineering is applied with forward engineering, reverse engineering, and restructuring as shown in the picture. This can improve software development productivity, reduce maintenance costs, and quickly respond to software requirement changes. To apply reengineering effectively, it is necessary to construct reengineering, forward engineering, reverse engineering, and restructuring based on the repository. The reengineering methods is applied as follows. Firstly, it is a restructuring. It is the process of maintaining the external behavior of the system and converting the same abstraction representation state to another representation form. Then next is a way of remodularization. It is the changes the module structure of the system, which relates analyzing and combining clusters of system components. Finally, it is a semantic information extraction method. It is a document-level design recovery method, not code level. In general, companies need reverse engineering as follows. If maintenance of existing system is difficult, when system efficiency is degraded due to frequent changes, if the work developed as a file system is rebuilt as a database management system, or when downsizing an existing mainframe system. The advantages of such reverse engineering are that it supports the analysis of commercial software, analyzes the data of the existing system to speed up the maintenance, and generates the documents of the system to obtain the system's information. So let's look at the input and output used in reverse engineering. First, input types include source code, object code, job control procedures, library, disk directory, text data, database structure, input-output form and data, and various documents. Output types include structure diagrams, data flow diagrams, control flow graphs, entity relationship diagrams, and data flow graphs. Types of reverse engineering include logical reverse engineering and data reverse engineering. The role of logic reverse engineering extracts information from the source code, stores it in a physical design information store, and obtains physical design information. Data reverse engineering plays the role of modifying an existing database or transitioning to a new database management system. On the other hand, an example of the abuse of reverse engineering to demonstrate the danger is the case of which various security programs have been breached. For example, there is a system to prevent anti-program installation on public computers such as libraries. That is, the system is reset when the hard disk is rebooted. This system additionally provides administrator mode for program installation, requires 4-digit password input. But if you use reverse engineering to find a routine that checks your password, you can also skip the password entry step. Internet banking with dozens of safeguards is no exception. Even if you use a secure public certificate, if you find a code that compares the entered password with the public certificate password and skip the routine, the password of the public certificate becomes meaningless. No matter how many safeguards you have, if you run a binary on a Windows machine, you can analyze it and remove the code. There is no effective solutions against this reverse engineering attack in the current MS Windows security model. The alternative we can do is make binaries complicated to analyze. The need for code obfuscation starts here. Code obfuscation is a way of converting programs. This is a technique that prevents code from being read through reverse engineering by making it hard to read. Obfuscation can be largely divided into source code obfuscation and binary obfuscation depending on obfuscation target. Source code obfuscation is a technique to convert the source code of programs such as C, C++, Java into a form that is hard to understand. Binary obfuscation is a technique that modifies the binary generated after compilation to make it difficult to analyze it through reverse engineering.
you.